Okay, welcome everybody. This is Riccardo talking to you from Italy. I'm a business intelligence and Power BI engineer in the Italian branch of Lucient, and I don't bother you on me. So let's go to the agenda of today. Today we talk about Power BI Dataflows. So it's a deep dive session, so we will try to look at inside the engine and understand exactly what is a Dataflows, what is behind the UI and behind all the cool tip and tricks that you can find in the UI. So let's start talking about Power BI Dataflows, and we will start with a recap. With a recap because we want to understand exactly what a Dataflow is. And we start with designing a scenario where Dataflows became very handy. Let's do an example. You are adopting Power BI and someone asked you to create a report that represents your sales. So you start from your sources and using a Power Query, that is the ETL tool that is built into Excel, into Power BI Desktop, you create the entities, the tables that represents your data. For example, customer, sales, and date. That is useful to create some time intelligence measures. At the end, with this data, you can create your beautiful report. And so far, so good. In a second moment, someone asks you to create another report for what concerns the purchase. So you start again from your sources, and with Power Query, you create the tables that are needed to create another beautiful report. So far, so good again, but as you can see, doing the same process in two different areas, in the sales and the purchase area, you created something that is duplicated. So you maybe duplicated the logic to create the same entity that is the date. And imagine that, for example, you have the same Power Query script to create that date. You can reuse it in many Power BI desktop file, but as soon as you have to change some logic, maybe a field name, a way you create a column, or the number of rows you populate in that table, you have to maintain that script in many places. So this is the way, this is the scenario where a Dataflow came very handy. So Dataflows is a new paradigm, a new way of developing, a new way of using Power Query. We start with our data sources. And in a browser, we do exactly what we have done in Power BI Desktop. So we create our Power Query steps. We create our M scripts in order to create different tables that we can reuse in our reports. Behind the scene, everything is saved into a data lake storage Gen 2 that is managed and that is managed by Microsoft. So you don't have to worry about it. You don't have to manage it because it's managed directly by Microsoft. Everything is done in cloud because everything is done in the browser from a Power Query interface in the browser. All the entities are saved behind the scene in the data lake, everything in the cloud. As soon as you have your data in the cloud, in the data lake, you can refer to them as using specific connectors that you can find, for example, in Power BI Desktop that refers to Power BI Dataflows. So you can refer to those objects calling the specific connector Power BI Dataflows. And you can also mesh up those Dataflows with other sources like Excel, like relational databases, structured, semi-structured, non-structured data, everything you want to create something that is that could be considered a golden data set containing all the information you need to build your reports. So in the end, your reports will use the Power BI data set that is a collection of data from Excel, from relational databases, from your entities in the data flows, and all the data sources that you want. And you do not have to reinvent the wheel every time. You have the single version of the truth thanks to Power BI data flows that are saved in the data lake. Using this new paradigm, you can separate many phases. You can separate data preparation from the data modeling and the data presentation. So this is the slide that you can pick up as a summarization of the data flows aim, the data flows goal. So you have to separate preparation, modeling, and presentation. And Dataflows could be your preparation tool built in the cloud. So as you can see here, we are referring to tables saved in the data lake as CDM folders. So when data flows are saved into the data lake, are saved in a specific format that is known as CDM. Let's start talking about this format because it's important to understand what is behind the scene. So CDM is, first of all, a metadata system. So a way of saving, it's a system that enables you to understand the data, describing them with metadata. And it's a project that has been started by Microsoft, Adobe, and I do not remember the third partner, in order to create a shared language and a consistency between different apps. So it means that if you have many applications that are CDM aware, you can make the interoperability between them much more easier. So for example, Power Platform application, Dynamics 365 or other Azure application, Azure services, Azure application are CDM aware, so they can interact exchanging data in CDM format. CDM common data model include also standard entities. So you can, for example, have the customer entity, the invoice entity, and other kind of entities of tables that could have a standard set of fields that you can map to your own data in order to create something that is standard. 9 out of 10, you won't use standard entities, but you will create your custom entities. So just a specific rule, when you see a CDM folder, it's just a folder, a storage that use the CDM metadata. But let's see exactly what is a CDM folder. A CDM folder that applies the CDM format is a folder like this. So you have a folder that has the name of the data flow, and inside you have a file called model.json that contains, that is the metadata file that describes the content of that data flow, of that CDM folder. Inside the CDM folder, I can see I have many entities. So inside our data flow, I can have many entities. And for each entity, I have a CSV file containing the data of that specific entity. I can have multiple files because I can manage multiple partitions for this entity. So this is the way Dataflows saves data into the storage. When you open the data lake where there's a data flow, you can find something like this. And we will see this in a demo in a few minutes. I think that it's very important to understand what they are and what they are not, because it's very likely that you will find a data flow application, but maybe you won't, but maybe they are not used for the right aim, for the right topic. So it's important to understand what they are and what they are not. They are a self-service data preparation tool in the cloud, in the browser. So we have already seen this, but we say it again. This is a data preparation tool because it's Power Query in the cloud. It's Power Query in the browser. And the data they prepare, it's saved behind the scene in Azure Data Lake Storage Gen 2 that by default, you don't have to worry about it because it's managed by Microsoft. The main aim of this tool is to encourage data reuse. So it means that someone prepared the data and place it in the data lake using this data flow, and you can reuse those data without reinventing the wheel every time. So think about the calendar table, the product table, something that could be prepared once per month, once per year maybe, and it's prepared and placed in a place you can reuse those data without reinventing the wheel. But it's very important to understand also what they are not. They are not a replacement for Power BI datasets. So if you are using Dataflows, you cannot get rid of datasets. You will have datasets. And if you remember my first slide, datasets are built on top of different data sources, and one of them could be a data flow or a collection of data flows. They don't replace a data warehouse because they are not a relational data warehouse. They are a collection of entities saved on a storage. They are not a database. And they don't replace something that orchestrating tool like Data Factory or SQL Server Integration Services or other tools that orchestrate. They do not orchestrate anything. Something that is very interesting is that they are not a premium only feature. So we will see what you can do with a pro license, and we will see what you have to do only with a premium license. And in general, you don't have additional costs to use them if you use the pro features, if you have a pro license, and if you use the premium feature with a premium license, you don't get any additional cost. I leave this table to you because it's very interesting. I picked it up from BI Polar blog. It's a blog from Matthew Roche, Microsoft person working very hard on Dataflows. And this is a very complete table that compare data flows and data sets. I leave this for your reference. We won't go we'll go through it right now, but it's very interesting to see each topic with the comparison between the two tools. What are the pros of using data flows? For sure, you have the possibility to centralize the data preparation. So you can ask people, maybe some technical people, to pick up just the preparation of data as their main goal, and they centralize the data preparation in something that is stored and reusable by other tools like Power BI, but also Databricks, Data Factory, and so on. You can have one very important pro, that is the possibility to isolate refreshes. You can reach one table refresh a time. And as you know, if you don't have a premium license, you cannot refresh dataset table one by one, but you have to refresh everything or nothing. So with Dataflows, you can create one data flow that contains just one table and refresh that data flow on its own. So you are isolating refreshes. It's very interesting in some specific scenario where you have to speed up some specific refresh that are very slow due to many tables that refresh, and they are not supposed to be refreshed. For example, the calendar table, you can create the calendar table and refresh it once per year, because at the beginning of the year, you create the content of the table once, and you don't have to refresh it every day. but maybe the invoice table must be refreshed every day. So isolating the refresh of the calendar will make the data set refresh much more faster because you are refreshing only the things that need to be refreshed really. There's something that exit the preview just I think 1 week ago or 2 weeks ago, and this is not in preview, but it's generally available. You can also attach a data lake, your own data lake. So you can save the result of Dataflows inside a data lake that is managed by you. And this is very useful when you want to integrate Power BI Dataflows in your pipelines, data pipelines that maybe exit from Power BI and end up into Databricks, into Data Factory, or anything else. So as I told you, when you isolate, refresh, and do some specific techniques in Dataflows, you could end up speeding refresh a lot. So let's see how we can create them. As I told you, it's something that is created directly into the browser. The user interface is in the browser. You cannot use any tool like Power BI Desktop or anything else. You have to use the browser. So you connect into powerbi.com and you connect to your workspace and you can create a data flow with four ways. And we will go through all of them. The first one is define new entities. So when you create new entities or new tables with the new way of calling them is tables, not more entities, you simply open up your browser, you define your Power Query steps as you would do in Power BI Desktop or in Excel, connecting to your data and transforming and meshing up them. And in the end, you will save the data in the data lake behind the scene. And as I told you, without managing it, it's done directly by Microsoft by default. So this is your Power BI data flows. You create your tables, and this is your data flows. When you are done, you can simply schedule the data flow and make it refresh according to your needs. Let's go to see this in action. So let's do a demo about this. So we create a data flow with the first method. So I hope you see my virtual machine. In this moment, I'm connected to Power BI Desktop, Power BI service, and I'm connecting to a generic workspace with a pro license. So I start, let me refresh the screen. Okay, so workspace, IT demo. So I start with the plus button here, and as you can see, there's the data flow possibilities. So as you can see, 4 ways to create them. Let's go with add new tables. So if you are aware of the Power Query experience, you can see something that is very familiar to you. So a bunch of connectors that you can start from. So you have a list of connectors to use in your data transformation. And for example, in my case, I can use Azure Blob Storage. So yeah, I choose that Blob Storage to get the data from. I can simply put the name of the data lake that I'm going to use, and I pass the key of my data lake. And doing next, this is more or less the same experience I have in Power BI Desktop and in Excel. So this connector is telling me that I have 4 different containers here. So I'm choosing a dashboard in a day container, and this will analyze the container and will tell me what I have inside it. So I put transform data, and what I'm getting now it's a data flow. So let me switch off this for a moment. So as you can see, I'm in in a browser, and I have something that is very similar to the Power Query experience inside Power BI Desktop, with the data preview in the middle, with the steps transformation on the right, and with the queries that are my tables on the left. So what I can do now is to work with this as I would do in Power BI Desktop or Excel. For example, I'm interested in getting the data for the Canada files. So I simply select the file I'm interested into, and I expand the content from the Canada file. So in this moment, you see that the file had been downloaded from the data lake. Yes, that's okay. And this is telling me how we will produce the content. So, and there it is. So I have my file here with Canada data, a bunch of steps that had been applied to the file, to the blob storage to get that data. And in the end, I can call this Canada. There are a lot of features here, but it's not a Power Query session, so I won't go through all of the possibilities you have here. More or less, you have all the possibilities that you have in the Power BI Desktop or Excel experience of Power Query. And you have other features that we will see that are very specific to the browser version of Power Query. What I can do is, for example, at this moment, I can see all the steps I have applied, and this is the data that I will save in the data lake. What I could do is to add something else. I could add some other table coming from all the connector that I have. So I can choose another type of connector, but I could also use something that comes from outside. So for example, here I have my Power BI Desktop file with a calendar table. So it's very important for me creating reports and data set that always have a calendar table to perform time intelligence calculations. And this is a table that someone prepared to me. And I would like to include into Dataflows for future uses. So what I can do is to simply access the Power Query that created this calendar table. And if I simply press copy on the calendar table in the Power BI Desktop, and I move back to the browser, pasting it, you can see that the browser tell me, hey, use Control V. So let me do this. I'm doing Control V, and boom, I have my calendar table ready with all the steps that I've applied in Power BI Desktop that is ready to be saved into Power BI Dataflows. So this is the calendar. I have the Canada table, and I can press now save and close. So with this activity, I'm saving all my work. I'm saving all the queries. It's validating our work, and it should save. Okay. Now it will ask me to give this a name. So I will call this hybrid demo 1. I can give a description, but it's not needed. So I have an object that is composed by two tables. As you can see, they have some field and they are very strictly defined. So they have a types, they have types, and something that calls this object can exactly know what is inside the Canada table. They know exactly the fields, they know the types and what is inside. In this moment, they don't have the data. The data are not saved in the data lake yet because I haven't refreshed the data flow. So let me close this. As you can see, I have the data flow in my workspace and I can refresh it now. When I push refresh, the data are picked up from the sources. All the ETL steps are applied and saved into the data lake. And I can start from there picking up the data and reusing them in other steps in my ETL process. So let me, while it's refreshing, let me show you this. You have different options here. You can see the lineage, so you can see the dependency of this data flow with other things. You can see, you can set up a refreshing scheduling refresh, so you can schedule the refresh. But you have also, you can edit obviously, but you have also the possibility to export a JSON file from the data flow. Let me do this. This JSON, I will open with Visual Studio Code. Let me format it in a better way. Let me zoom it. So what we are seeing now, it's, if you remember the content of a CDN folder, and if you remember, there's a specific file that is called model.json. This is the model.json, and this is the way this data flow is describing himself to other software that could connect to this data. As you can see, there's the name of the data flow, and there's the content, the tables, and the object contained inside the Power Query. So this is all the Power Query object, Canada sample file, all the queries inside the ETL. In this document, there's the whole ETL, the whole M script behind, and down below in the entities, you can see the list of the entity contained inside the data flow. So you can see there's Canada, there's the calendar table, and the attributes that describe the fields of this table with their name and their types. And very important to see right now, it's the type. So you can see this table is a local entity. So this indicates that as being created with type 1 field, the type 1 data flow. It's a table added with the first method. Let me close this and go back to the browser and see if the refresh is ended. Yes, the refresh is ended. Let me export it again. And now I show you another thing in the same document. Now the process ended, and as you can see, there's something more near the tables. So near Canada, I can see a new node that is partition. The partition is called part 001, and as you can see, there's the location. This is an Azure Data Lake storage that is managed by Microsoft, and this is exactly the location of the file that contains Canada data, and the same for calendar. So this is the location of calendar data. So this is the way behind the scene data flow is working. Okay, so let's go back to the slides. Method number 2, it's the second square, and it's called linked tables. So imagine that you have a data flow with some tables like the calendar and the Canada data that we have. And you create another data flows that reuse a table from another data flows. This is called linked entities. So you are just referring to a table that is contained somewhere in another data flow. You can also start from this table and change this table, maybe adding another field, removing some records, or doing some other task. This make a linked table that is a read-only table, transform this table in another thing that is called computed table. That those two tables has different icons, and they are different because the linked table is just a link to another table. The computed table is a different table, a table that has some transformation. And behind the scene, what is happening is something that is called in-storage transformation, because you start from data that are saved into the data lake, because this is the storage where data flows rely. and behind the scene you apply some transformations and you save the data again in the blob storage, in the Azure Data Lake storage. Everything is done by Dataflows behind the scene, and you don't have to worry about it. It's something that happens behind the scene. The only thing you have to be aware is that since in storage computation, in storage transformation is done behind the scene, it's a very expensive task. It's something that is available only in premium capacity. So this is the first thing that you cannot do if you are not in a premium capacity. As you can see, you are creating with a linked table something that is a father and son data flows. So there's a dependency relationship between two data flows. When you have this kind of relationship, you can refresh both of these two data flows and you will end up with different behaviors. So for example, with this matrix, I try to explain you which is the behaviors. So if you refresh the source data flow, and both source and destination data flows are in the same workspace, when you refresh the data source, the data flow that is the source, both of them will be refreshed. So you refresh the source and automatically the destination will be refreshed at the end of the source refresh. If they are in different workspace in Power BI, the refresh of the source will be only the refresh of the source. So this is interesting and important when you have to understand exactly what will be fired when you refresh a data flow in your ETL pipelines. And obviously, when you refresh the destination data flow, you are only refreshing the destination data flow, even if in the same workspace there's a source data flow. Let's see this directly into a demo. So let's go back into our workspace, and now I start again with the plus button, hitting data flow, and I want to use the second method. So I'm using the add linked tables. For a sec, as you can see, I don't get the connector, the connector choice, but I get the Power BI data flows connector by default, because this is the connector that I'm using. I'm connecting to an existing data flow. So I sign in my credential. So it is connecting to my workspace. When I hit next, it will analyze all the data flows I have access to. It gives me all the workspaces that contain some data flow. And for example, this is hybrid demo. So this is the data flow that we created a few minutes ago. And you can see that we have the tables. So I'm interested in using a calendar table in the next data flow that I'm creating. So I can select that table. And as you can see, I have my table ready with a specific icon that is the link. It's very interesting to see that. Let me open the advanced editor here. So you can see the step that had been applied to get that table. So this is the step to get those data. As you can see, I'm not getting the data from a table. I'm not getting the data with transformation. I'm not doing anything. The only thing I'm doing is to get the data flows from where I want to connect. First of all, I connect to a workspace, then I connect to a specific data flow, and then I get the calendar, the specific entity I'm interested in. I'm interested to get the data from, that is the calendar. And the result is placed in my calendar here. So I'm not doing any transformation, and everything that I have to add to this transformation must be done into the source. And here I have a link. It's like a view on a table, more or less. But as you can see, it's saying that linked tables cannot modify it. Any changes made to this query will transform this table to something else, and I will be required to have a premium to perform refreshes. So for example, if I try to duplicate this table, or better, I try to reference this table to do something else, for example, removing some fields that I'm not interested to use, for example, this one, remove columns. Now this became computed entity because this is doing a transformation on something that has already been stored on the data lake. So I'm asking to the engine to perform something that is very expensive from a storage perspective. So doing a transformation from a storage from a CSV file to another CSV file, doing transformation. This is very expensive, so this is a premium only feature. What happens if I disable the load of the calendar, that is the base of these computed entities, is that this table, it's not a computed entity anymore, a computed table anymore, because I'm not saving the calendar table anywhere. I'm simply pushing this transformation to the source. So it's not a in-storage transformation anymore. This is very important to understand how can I reuse my data and why I get computed entities behind the scene. So if I enable the load, I'm saving the calendar table in the data lake, and on that data lake, I'm applying a transformation and then saving again in the data lake. This is in storage transformation. It's very expensive. So this is a premium only feature. So let me save this into my workspace. Okay, let's give this hybrid demo 2. Save this. As you can see, this do not rely on a premium capacity, so I cannot refresh this. And I have these two different tables. One is the computed entities. The calendar 2 table is a computed, and the calendar is a linked table. So I cannot see anything in the calendar because everything that I need to see is in the source data flow. So I have to navigate with this link. So let me go back for a sec on the workspace. I see the hybrid demo data flow, and let me export the JSON for this. Let's see this together. Let's see what is behind the scene when I use this kind of this strange entity, these strange tables. As you can see, the calendar, the first one, is named as reference entity, and I can see that in the annotation, I see that is referencing a model ID. This is the name, the ID, the internal ID of the data flow and the specific entities that I'm referring to. So I have no attributes, I have no types, I haven't anything because everything is saved on the source. It's different for the calendar 2 that is a computed entity and is saved as a local entity because I apply changes to that. And as you can see, it's marked as calculated entity. If I have permission to refresh this data flow, when I refresh the data flow, I will see there the partition after the data are saved into the data lake. When I use linked entities in my data flows, I have always references models in the JSON summarized down below. So this is exactly the ID of the workspace and the ID of the data flow. Let me check if I can show you this. So this is, trust me, they are the same. So this is the internal IDs that I'm referring, and this is the data flow where I'm getting the data. So the original hybrid demo 1 data flow. And this is the way I can use linked entities and computed entities, or tables with the new naming convention. We have a method number 3 to analyze. It's pretty straightforward. So you can import a model. When you have a model.json, you can import it directly into your workspace. So you simply import model, you give it the model.json file, and the metadata will be imported, and you can refresh the data into the workspace. It's a pretty, it was a pretty handy way to migrate something from, for example, from development environment to production environment. So you are developing your data flows in dev environment. When you are ready, you pick up the models and you put them into the production environment, and you hit refresh, and data are saved also in the production environment. Pretty easy, pretty simple. And then method number 4, that is the method that start to create a correlation between data flows, Power BI data flows, and other applications that are CDM aware. So this method means to attach an existing CDM folder. So you can attach a folder to your Power BI data flows, a folder that has been created by Data Factory, Databricks, or Dynamics 365. Anything that is CDM aware can produce something in a data lake, and you can attach that folder according to the CDM if it's CDM aware. So something creates, and Power BI data flows use that folder. This ends up the way of creating Power BI data flows. There are some premium features for using data flows. One of them, we have already seen it, the computed entities and the linked entities. You have to buy a premium license, a premium capacity to use them. So your workspace must be backed by a premium capacity to use them. There's another premium feature that is called Enhanced Compute Engine. It's a very powerful feature that you can use, but you have to use it in very specific scenarios. Let's talk about it. Let's imagine that you create some data flows to create some entities, and you save them into the data lake. Now you create another data flows that merge these two entities into one. For example, you have the customer table and you have the sales order table, and you want to merge them to have the both customer and invoice data into the same table. What it happens here is that query folding, that is the possibility to push the predicate down to the source, in some case happens in the other not. When you have relational databases or sources like that, you can push the predicate down to the source. And when you start from the sources, you can push predicates and save the data into the data lake. But when you start from data lake to merge something, to transform something, as I told you, you are performing in storage computation that it's very expensive. And in this case, query folding could not happen because they are CSV files behind the scene. So what Microsoft invented is another process that is called Enhanced Compute Engine. So when you start getting the data from the sources, data are saved into the data lake, but behind the scene, they are also saved in the cache in an Azure SQL database that is created and managed behind the scene by Microsoft. And when you perform some specific functions like the merge, the data flows won't use the data that are saved into the data lake, but will use data into the data lake. that can use the cache, they can use the indexes on a SQL database, they can use something that support query folding. So they can push predicates to the source and they can speed up refresh. How can I apply this? It's very simple. You have to be a capacity admin in your Power BI ecosystem, and you have to simply switch enhanced Dataflows Computer Engine to on. And you can reach very powerful results, like up to 25 times faster than a standard Dataflow. But remember, first of all, you will suffer slower loading data at the first step, because at the first step, your data will be saved in two places, into the data lake and into the Azure SQL database that is managed behind the scene. And you have to be aware that an asset compute engine works only for specific tasks like merge tables. When pushing the predicates and doing query folding can speed up your refresh. If you are not doing this, you won't get any benefit from enhanced compute engine. So be aware of that and don't switch it on without thinking about it. You have also the possibility to implement some AI with premium features, so calling machine learning models or doing some sentiment analysis or language detection and so on, directly in Dataflows from their interface. You can use the incremental refresh, so you can refresh some specific part of the data in a specific Dataflow without importing every time all the tables, all the content of the table. And this more or less ends up the premium features. There's another very interesting scenario that is the possibility to use your own data lake. So you use a data lake that you have already bought in Azure. So in this case, we switch the roles. So you have Power BI Dataflows that create the data in the data lake and other application that tries to use those data using a specific data lake. And let me show you one thing. You can do this configuring the data flows, configuring a workspace in Power BI to use this functionality. So in the settings of the workspace under Azure Connection, you can set up a storage, specific storage where you want your data flows to be saved. And what happens is that when you have a data flow in your workspace and you refresh it, your data will be saved into your data lake. How I can verify it? I download the model.json and I open it. This is the JSON behind. And as you can see, I'm not using a Microsoft data lake anymore, but I'm using this data lake that is my data lake. And the result of this is a CSV file that can be used by other software that can pick up this file and put this into other data pipelines. So this opens a lot of different scenarios. Let me close very quickly our session because we are very close to the end. There are some best practice. So try to split ingestion and transformation in different data flows. So this will cost you maybe to have computed entities and linked entities. So try to do this if you can. It will be easier to you to maintain the different data flows that perform different operation. Try to separate workspace for ingestion and transformation, and try to not to break query folding. So try to push every time predicates into the sources. This will make your query faster. And try to separate data flows that pick up data from on-premises source from data flows that pick up data from cloud sources. Some other tips and tricks. You can use the on-premises data gateway, so you can pick up data from on-premises. as far as I know, you have to be on the same gateway for all your query. I don't know if it's real in this moment, but as far as I know, this is true. And a suggestion, if you don't find a specific connector in the UI, you can also try to use the blank query. The connector may not be already published, but you can use the blank query and put and use a query with the Ctrl+C, Ctrl+V, as you already seen with the calendar, or you can create your M script from scratch using blank query, and maybe you will find that you can use the same connector without seeing it in the UI. So we have some cool features around. There's the endorsement, there's a possibility to use direct query, and maybe sometime, I don't know when, I've seen an announcement. I cannot understand exactly when. There could be the support for manifest. That is a new way to create the model.json with something that is called manifest, not model. Other cool features that you can find only in Power BI Dataflows are the folding icons or the diagram view. I don't really like the diagram view, but I see a very high on the web for this feature. I really hate it, to be honest, but that's it. I leave here some useful links, and I hope we have time for some Q&A.
Yes. Thank you, Riccardo, for this thorough walkthrough through the data flows. But still, even though it was very good, we have some questions for you.
Yes.
The first one, what is the benefit of doing this in Power BI instead of Synapse Analytics or other data integration components?
Yes. Okay. So this opens. Well, we could start with it depends. That it's the always true answer. Using Power BI, it's always easier for people that are very comfortable with Power BI. Maybe you have a team that is using a Power Query and Power BI forever, and they are very used to the interface, and they have already maybe M scripts, transformation already in place that they can reuse and put them into the data lake. If you have other tools, you could use other tools to create the same output and reuse that output also in Power BI. So this is a way of creating data reuse culture inside the Power BI ecosystem. The possibility to expose this data to other tools opens a lot of other scenarios, and two of them are in my slides, where you can see the data flow that could be something that creates data or consume data. So Power BI is an actor in your ETL or data scenarios, and it could be data creator or data consumer. And since it's very connected to the Power BI ecosystem, you can reuse it very quickly using the native connector that you have in Power BI Desktop, for example, that makes it very easy to get this data and to reuse these logics. So
okay,
it depends by your scenarios.
Excellent. So when you create a Power BI data flow, could you also access the CDM that's pushed down to the data lake from another application such as Power Apps concurrently with Power BI consumption? And also, if that is true, did I also hear you correctly say that you can consume this content from Databricks?
Yes, this is exactly the aim of a tool like this. As I'm showing you right now, the data that had been created by this data flow are stored into a custom data lake that is accessible. Obviously, if you have permission to access this data lake, you can connect to it and consume this data. So, for example, you can use applications that are CDM aware, or the application that can simply pick up CSV files. So this is very, very easy to get the file from the containers of this of the data lake. So you can get the data from the data lake. To be honest, there's a current limitation that I'm not sure when will be fixed. Not to do I don't want to do too much advertisement to me, but I've written about it in a blog where I'm showing you how to try to connect something that is a data flow output with Synapse or Data Factory that should be CDM aware. As you can see in, let me zoom it a bit, there should be a common data model connector that can see something that is contained in a data lake and something that's been produced by a Power BI data flow. To be honest, I don't know why, and I tried to contact also Data Factory team. There's no answer to this. And for some reason, in this moment, Data Factory and Synapse are not able to pick up using the common data model connector data directly from the Power BI data flow. So you end up with some strange error like this one, no output data or something like that. And this is the same for Synapse. Even if the data you are seeing in the data lake are in this format, so you have CSV files and you could pick up them from there. I've seen many people arguing on this issue, and I don't know exactly when it will be fixed. I'm assuming when Power BI data flows will move to the new format that is the manifest, but I cannot swear.
So this goes for a question from one of the people in the audience that was anonymous. Does this mean that a data flow contains actual data? And I think the question would be short, right?
Yes. The data flows contain data, and they are in CSV format.
Perfect.
Just on the CSV side of things, obviously, if you've got very big data sets, then Parquet might be a nicer option. Do you ever see that being a possibility at some time in the future?
Well, it's a very interesting question. I hope, because Parquet it's able to push predicates down to the files. The structure behind it's quite similar to Parquet. I can try to show you exactly what is behind the scene. What I'm trying to show you, this is the storage behind. So as you can see, there are snapshots. There are some CSV files here. So in this folder, it stores snapshot of the same file and switch the pointer to a specific snapshot of the file with the data. This is something that you can find also in Parquet or in Delta Lake. Something similar, not in this way, but it's very similar, and maybe one day they could switch to that approach. It will be much more faster, I think.
Okay, brilliant. Okay, so I think given the time, we'll limit this to the last question. So this one comes from, hopefully I'll say this correctly, Lazaros Mavropoulos. Which approach is best? Number one, and I think this is something you did at the very beginning. Number one, copy the M code, or do this as you did in your demo, copy and paste. I think it was the table, wasn't it? That you...
Oh, yes, it's the same. It's the same because behind the scene is doing the same. So you can copy and paste, but one thing it's very interesting. I think it's when you copy and paste the M code. So you go here with the calendar and you do advanced editor, and you simply copy the whole text and you use the blank query in the data flow to create this table. You are doing simply this. But when you have multiple entities here multiple tables that you have to bring into the data flow, into the cloud, you can select all of them and doing a copy, you bring them in a bunch. So you group them and you put them with a simple Control C, Control V, without doing multiple, advanced editor, copy, paste. Another one, advanced editor, copy, paste, and that's it. So one shot, maybe it's faster. And another thing that I think it's very interesting is that when you copy a query that maybe is dependent to other queries, because for example, you created this calendar and we do the reference. When I copy the calendar to and I paste it in another, in a data flow or in another Power Query file, it will pick up also the dependencies. So I will find the calendar 2 and the calendar entity in the data flow and in the Power BI file or in the Excel file. So this way is faster, but in the end, it's the same.
Cool, thanks. And that would conclude the questions. I say thanks to everyone for joining us and a big thanks to Riccardo.
You are welcome, guys. Thanks for having me.